Okay, so let's take a look at go back in action. So here we have a sender and a timeline and the receiver. So we're going to send packets 0 through 8, and we have a sender window that allows for 4 packets. So basically n is set to 4. So imagine the sender basically sends out 4 packets, packet 0, 1, 2, and 3. The receiver receives packet 0, sends the acknowledgement. The sender sends packet 1, the receiver sends packet 1, sends the acknowledgement. The sender sends packet 2, but it's lost. The receiver receives packet 3, but because it does not, it realizes, because it has a sequence number, it realizes that it did not receive packet 2, so it discards it. It does not send it back. Does not send it to the application. It discards it and resends the acknowledgement for 1. Remember what we said, the receiver doesn't send any acknowledgments after a lost packet. So it resends acknowledgement for 1. In the meantime, after receiving the acknowledgement for 0, the sender sends packet 4, which gets discarded. The receiver receives acknowledgement 1, sends packet 5. This guy discards it. He sends packet 1. So at this point, it's been too long for the to receive the acknowledgement for packet 2. So a timeout occurs. So the sender knows it received 0, an acknowledgement for 0 and 1. So now it resends, starting with packet 2, and sends packet 2 through 5. So as you can see, what's happening is a sliding window. When it sends acknowledgement, it slides over 1, allowing for packet 4 to be sent. Then when acknowledgement 1 happens, sliding window slides over 1 again, allowing packet 5 to be sent. Then basically, when the packet 2 timeout occurs, it starts the beginning of where the window is, and so it sends packets 2 through 5. Next, let's talk a little bit about selective repeat. In selective repeat, the receiver individually acknowledges all correctly received packets. It buffers packets as needed for eventual in-order delivery to the upper layer. So that's different from what happens in go back in. Unlike go back in, where we send all the packets back in the window if there's when we have to resend. In selective repeat, the sender only resends packets for which an acknowledgement has not been received. And there's a sender timer for each unacknowledged packet. And there's a sender window with n consecutive sequence numbers. This limits the number of sequence numbers of sent unacknowledged packets. So it basically doesn't have an infinite number of sequence numbers. It just has some number n sequence numbers. So you kind of see what's happening here is this basically results in less traffic on the network, but it also means more work has to be done by the hosts themselves. And that's kind of a trade-off. So here we have the sender and receiver windows of using selective repeat. So here's the sender's view of the sequence numbers and the receiver's view of the sequence number. So you have your window size of n, and you have packets that have been sent, so the yellow and the green ones have been sent. You receive acknowledgments from the green ones, but no acknowledgments from the yellow. These are within the window, so they are usable, but they haven't been sent yet. And what our next sequence number is at the beginning of the next usable packet. On the receiver side, we have some packets that are received out of order. We don't discard them like we do at Go Back In. We basically buffer them until we get the ones that we expected. We've expected to get these two. We have not received these two yet. And these packets are within our window.